Hello everyone, we are going to discuss OPAMP as an intregrator. Prior to this talk, we have already discussed about the properties of OPAMP and a few examples how it can be used. For using OPAMP as an intregrator, we have to construct the circuit as follows. This is a circuit for OPAMP as an intregrator. Here we have used as an OPAMP. A feedback capacitor is used here. We consider as a C capacitor, which has capacitance C, resistance R, voltage, input voltage is applied the inverting terminal via some resistance R, and the non-inverting terminal is grounded. We consider V out. Let's consider V out with the output voltage and Vi with the input voltage. So input voltage we applied is equal to Vi, and output voltage we are considering is Vo. Let this is a point A and this is a point B. By the concept of the partial ground, we already know that Va is equal to Vb is equal to 0. 0 because the non-inverting terminal is grounded. So this potential is basically 0. By the concept of the partial potential, so we can say that the potential at this point is equal to potential at this point, equal to same. So it's a 0 both. As we are applying certain voltage to the input terminal, so it will carry current. So let some current is flowing through this direction. Let some current is flowing through this direction. Some I current is flowing. I input current is flowing, and the capacitor, due to this current, the capacitor is getting charged. At any instant, we can say that the capacitor is charged Q. Q is a function of time t. So we can say that the instantaneous charge accumulated in the capacitor Q can be expressed as C into voltage across the capacitor. The voltage across the capacitor we can write V A minus V out. So the current through the capacitor can be expressed by differentiating it Q function time d by dt C Va minus V naught. As the capacitor is capacitance of the capacitor is constant, so we can write so it's a current I, the feedback current basically. We can write C d by dt of Va minus V naught. We are writing the equation number 1. Again, the current through the feedback terminal, current I, we can write here is as the current I is nothing but the voltage difference, input voltage minus the voltage at point A divided by the resistance R. So we are getting the current through the resistance R is like this. So we are considering as equation number 2. Using the Kirchhoff's current law, we can write current through the resistance R is equal to the current through the feedback capacitor. Thus, we can just equate equation 1 and equation 2, and we can write by equating the equations 1 and equation 2, Vi minus Va by R is equal to C d by dt Va minus V naught. Again, we already have discussed that the potential at point A is nothing but is equal to potential at point B, and is already grounded, so it's a zero potential. So V is practically zero because the non-inverting terminal is grounded. So this implies that Vi by R is equal to minus C d by dt of V naught. So this is zero basically. This term is zero, so we can write like this. So the output potential V naught can be written as 1 by RC. So the C can be if we divide through the equation by C, we can write 1 by RC. So integration of Vi dt. So the output potential appears as the integration of the input signal. The OPAMP in the circuit can be expressed as an intregrator. So in the next class, we will discuss OPAMP as a differentiator. So thank you everyone.